Hi dear students, today we are going to learn about linear programming modeling. So we will be discussing the problems we will come across in our industry in working at different manufacturing organizations particularly. So I will be simplifying the problem so that it would be easy for you to develop the linear programming model. And when the linear programming model is developed, you can easily solve through graphical method. So let's start with the first problem. So you see over here, when Tracy McCoy wakes up Saturday morning, she remembers that she promised the PTA she would make some cakes or homemade bread for its bake sale that afternoon. However, she doesn't have time to the store to get ingredients, and she have a short of time to bake things in her way. Because cakes and breads require different baking temperatures, she cannot bake them simultaneously. Okay, so this is the problem we have come across, and you see in that what data is given. The data is given that the bread and cakes has to be made. Okay, and there is a time constraint we came across. Plus, you see cakes and breads require different temperatures. Baking temperature, she cannot bake them simultaneously. She has only 3 hours available. So she has only 3 hours available. That is a time constraint. And in the 3 hours, that is 180 minutes. She has to uh, bake the both things, bread and cake, both things. So it's a challenge now. So if you see constraint over here, you see time to bake cakes or bread is 3 hours. That is equal to 180 minutes. If you would take 180 minutes, you will have to solve in that manner in the minutes. The answer will be in minutes. So I recommend you to go with the hours, because the if you would solve with the graphical method, the linear programming model into graphical from the graphical method, it will be a lot easier for you to develop a graph of hours. So we have a choice to take into minutes or hours. Your graphical solution will be easy to manage if you take in hours. So let's move ahead. A cake requires 3 cups of flour. Now here we are given the recipe, that what does cake require and what does loaves of bread require. A cake requires 3 cups of flour and a loaf of bread requires 8 cups. So flour is required in different quantity for the cakes and the loaf of bread. And it is also given that the Tracy how many cups of flour the Tracy has. So Tracy has 20 cups of flour. 20 cups of flours. So in that you see 3 cups of flour for cake and 8 cups for bread. So, and Tracy has 20 cups of flour. It means she can made the bread and cake within the 20 cups. So the equation would be less than in equals to. And the equation you see over here, flour equation, is 3x plus 8y. X is number of cakes to bake. Y is number of loaves of bread to bake. So you see, first you need to identify the X and Y, because cakes and bread has to be made. Okay, so cakes, you see cakes not in loaves. not in pastries, but bread is in loaves. Okay, and we are given with the constraints that was time constraint that was discussed before. Now the flour is another constraint. So with this equation, with the flour constraint of 20 cups of flour, you are using 3 in cakes and 8 cups in bread. So that's how you are managing the flour. Remember, equation would be made like this: plus 8y less than and equals to 20, because 20 is the maximum number. Now let's move ahead. The PTA will sell a cake. Sorry, a cake requires 45 minutes to bake and a loaf of bread requires 30 minutes. So you see 45 minutes for cake and 30 minutes for loaf of bread. Okay, so total time was given maximum 3 hours. Okay, so I have written 180 minutes. Okay, I prefer you to use 3 over here. If you would use 3 over here, so the equation would be like this: 45 by 60 plus 30 by 60 y less than and equals to 3. Because this 45, you see 45 minutes, it has to be in hours. This 45 minutes, it has to be in hours. That is why it is divided from 60. Okay, so when you simplify it, 45 and 60 from 15, you see both will be divided by 15. 3 by 4 would be here. If you will divide both by 15, the 30, the 1 by 2 would be here, and this equation would be like this. Remember, the non-negativity constraint will always be there with the every constraint. And you see the PTA will sell a cake for $10 and a loaf of bread for $6. $10 for cake and $6 for loaf of bread. So this is the maximization of profit, because it is the, you see, it is the revenue. Okay, so that's how it goes. So the profit function would be like this. Okay, so I hope your concept are clear. Now you have a choice: either you go in any way to solve this problem. The preferred way is the graphical method. Thank you very much.